You want to leave the Milky Way. It's a thought both audacious and deeply unsettling. Our home galaxy is a sprawling, self-contained island of stars, a gravity well 100,000 light-years wide. To leave is to sever a connection that has defined our existence since the dawn of consciousness. It is a journey into the profound, terrifying unknown. The ambition is galactic, but the physics are local. You don't just leap into the void. You must climb, rung by rung, out of a series of nested gravitational prisons. Start small. First, escape Earth. Then, escape the Sun and its entire solar system. Only then, after conquering our own cosmic backyard, do you even begin to face the true challenge: escaping the galaxy itself. Each step has a price, paid in a currency called delta V, a change in velocity. Earth demands a steep toll, about 11 kilometers per second. That's Mach 32. It's a speed that could circle the globe in under an hour. The Sun, from Earth's orbit, asks for a far greater sacrifice, roughly 42 kilometers per second. These are not just numbers. They are brutal engineering problems, representing mountains of propellant and the absolute limits of chemical rocketry. So, we cheat. We become gravity thieves. Instead of burning fuel, we steal momentum from giants. Planetary slingshots are a cosmic dance, a precise trade where a spacecraft swaps its trajectory for a massive boost in speed. We use a planet's immense orbital energy to fling our tiny probes into the outer darkness. But this is a high-stakes ballet. Miss the aim point by a hair, and your mission is over. You could be flung into the wrong orbit, sent crashing into the planet, or cast away on a useless trajectory into the void. The masters of this craft stack assists. They stage propulsion burns with gravitational nudges, turning the solar system into a grand celestial pinball machine. They design orbits that become interplanetary highways, paying out dividends and velocity that would be impossible to afford with fuel alone. This is how Voyager 1 and 2 became our first interstellar emissaries, by borrowing speed from Jupiter and Saturn. But even the speed gifted by our entire solar system is pocket change compared to the galaxy's demands. Near the Sun, the galactic escape speed is a staggering figure, hundreds of kilometers per second, somewhere around 530. That's fast enough to cross the continental United States in about 8 seconds. Why so impossibly high? The answer lies in what we can't see. The stars, gas, and dust of the Milky Way are only a fraction of its total mass. The rest is an invisible, enigmatic substance, dark matter. A colossal dark matter halo cocoons our entire galaxy, extending far beyond the visible disk. This extra mass means extra gravitational pull, a deeper well to climb out of. You aren't just escaping the 100 billion stars that shine. You are fighting the gravity of 5 times that mass, a silent, unseen anchor holding you in place. So, how do we pay this astronomical speed bill? Conventional engines won't cut it. We need tricks, and we need engines bold enough to rewrite the rules of propulsion. Consider beamed light sails. The concept is elegant. Ride a wave of pure light. A powerful planet-scale laser array focuses a beam on a vast, ultra-thin sail, pushing it with the relentless pressure of photons. There's no heavy propellant to carry. The engine is light years away. The push is gentle but constant, accelerating the craft for years, even decades. The craft itself is a delicate, wafer-thin marvel, but the infrastructure required is colossal. It demands precision pointing across astronomical distances, power outputs that could dwarf our entire global energy consumption, and a commitment measured in generations. Or perhaps we bottle a star. Fusion drives promise, the power of the sun at your back. By fusing light elements like deuterium and helium-3, these engines could generate exhaust velocities 10,000 times greater than a chemical rocket. It's a far more balanced ticket. High thrust, high efficiency, but it comes with deep complexity. We must learn to initiate, contain, and sustain a fusion reaction for centuries. Then there is the ultimate fuel, antimatter. On paper, its energy density is perfect, converting 100% of its mass into energy. The catch is everything else. Making antimatter is fantastically inefficient. Storing it is a nightmare of magnetic containment fields. And using it means perfectly controlling an annihilation event, because one catastrophic failure would not just end the mission, it would vaporize it. For the truly daring, there's the ultimate gravity assist. A black hole slingshot. A dive near Sagittarius A, the supermassive black hole at our galaxy's core, could provide an unimaginable velocity boost. But the margins for error are non-existent. One misstep near the event horizon, and the mission ends not in a blaze of glory, but as a stream of superheated plasma, torn apart by radiation and tides. Even if you achieve the necessary speed, the journey itself is a battle for survival. Space fights back. The void is not empty. High-energy cosmic rays, particles accelerated to near light speed by distant supernovas, will relentlessly sandblast the hull, degrading materials and threatening any life or sensitive electronics aboard. Micrometeoroids, tiny grains of dust and rock, become hypervelocity bullets, capable of puncturing shields and crippling systems. The interstellar medium, a tenuous soup of hydrogen and helium, is negligible at planetary speeds. But at a significant fraction of the speed of light, it behaves like a storm. It creates drag, slowing you down. The constant impacts sputter away your ship's outer layers, and the friction builds up a powerful electrical charge and intense heat on the bow. Your ship must be a fortress, armored against a 1,000-year siege. The timescales involved are sobering, almost beyond human comprehension. With our present technology, like the Voyager probes, it takes centuries just to exit the heliosphere, the protective bubble of our sun. It will take them tens of thousands of years to clear the Oort cloud, the sun's last faint gravitational outpost. Even with our most optimistic future technologies, a breakthrough Starshot-style sail reaching 20% the speed of light, or a sustained fusion drive, the journey is monumental. Such a craft would still need hundreds of thousands, or even millions of years to truly leave the gravitational grip of the Milky Way's dark matter halo. This is not a voyage for a single crew. It is a project for a species. And what is the destination? Intergalactic night. A profound, crushing blackness, punctuated only by the impossibly distant smudges of other galaxies. The familiar constellations are gone. The comforting glow of the Milky Way's disk is now just an object in your sky. The star fields that have filled our nights for all of history thin to a lonely whisper. From this vantage point, the local group hangs like a faint, ghostly chandelier. The Milky Way and Andromeda, two titans locked in a slow, inexorable gravitational dance, destined to collide in billions of years. You are an observer of cosmic destiny, adrift in the space between worlds. Out there, your motion is a truth serum. There are no more planets to boost you, no more solar winds to ride. Your velocity is a pure accounting of what you started with. It is a testament only to the engine you brought and the light that was once lent to you. And yet, we try. Every probe we launch, every test of a solar sail, every new concept for a fusion reactor, each one is a small, uncertain step. Each is a rung on the colossal ladder out of our gravity well. We are learning the language of the cosmos. We learn to borrow gravity from giants. We learn to ride the pressure of light itself. We learn to dream of bottling fusion long enough to matter. Terror and beauty share a border. The desire to explore, To know what lies beyond the horizon lives on that edge. The galactic bill is steep, a debt of mass, speed, and time. But with every new telescope, with every new equation, the map is getting clearer. We learn the wells, we count the kilometers per second, we learn to spend momentum wisely. Because leaving the Milky Way isn't a fantasy, it's a problem set. Incredibly hard, yes, but solvable, piece by piece. Keep building the sails, keep taming fusion, keep stealing speed. The path to intergalactic night begins now, with the courage to ask the question.